welcome to this IChemE Global Awards webinar. My name is Matt Stalker and I'm your host for today's presentation. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely recognised as the world's most prestigious chemical engineering awards. Today we'll be announcing the winner of the IChemE 2020 Process Safety Award, sponsored by PM Group. This award recognises the project, process or product to best demonstrate excellence in process safety. And joining us now is PM Group Head of EHS, Shona Turner, and Principal Process Safety Consultant, Robert Rutter.
Good morning, everyone. My name's Shona Turner. I've been a process engineer for 24 years, chartered chemical engineer, and I've worked in many industries around the world. For the last 4 years, I have been head of the EHS department for PM Group in the UK. I'd like to introduce one of our principal process safety consultants, Rob Rutter, and he will just give you a background to himself.
Well, good morning, everybody. As Shona just said, my name is Robert Rutter. I'm a Principal Process Safety Engineer with PM Group, and I have approximately 34 years experience spent predominantly in the specialty and fine chemical sector, predominantly based in the United Kingdom. Thank you.
So we'd like to give you a presentation now. We'll be turning our cameras off to do that just a few minutes before we get into the awards themselves. Thank you. Hopefully now everyone can see my screen. Oh, I think I've got the wrong screen on, have I? Can you see my screen, Matt?
We can see your screen, but it is the wrong view. So if you just switch to the...
sorry, that one there. Yeah. Now, hopefully that's better now. Okay, fantastic. Thank you, everyone. So, first of all, PM Group have a long history with the IChemE, and we're delighted to be sponsoring the Process Safety Award for our second year. On the screen is a list of today's finalists, and we offer you many congratulations for being shortlisted for this fantastic IChemE Global Award. And I'm looking forward to hearing the presentations over the course of this morning. Good luck to you all. This award is a fantastic way for PM Group to continue to raise awareness to the importance of process safety. As a company, we have a number of IChemE accredited professional process safety engineers, including Rob. One of our senior process safety engineers is the current chair of the IChemE All Ireland Members Group, and one of our process safety colleagues in Ireland led an industry SME group to design a third-level process safety course at the Cork Institute of Technology. So before I hand over to Rob to go through some specific case studies, I'd like to give you a brief overview of PM Group and our process safety offering. So we are a 47-year-old employee-owned company with over 2,600 personnel, which includes approximately 100 dedicated environmental safety and sustainability resources. And we are across 15 offices worldwide and have many more sites, active sites. The sectors we work in are listed here on the screen. We offer process safety expertise for both company-led projects and as a standalone offering to clients across all of these sectors. We're a full multidisciplined architectural and engineering firm offering a range of services from site location, master planning, design and construction. We provide full environmental safety and sustainability services alongside the engineering and construction. Our managed service offering provides teams of people on client sites delivering their small CapEx project requirements, including their safety requirements. And our outsourced technical services offering is where we provide targeted technical resources to fulfill our clients' requirements. So, our process safety expertise. The 4 boxes represent the 4 main pillars of our process safety expertise. So, our full process safety services covers process hazard analysis, including LOPA and SIL, fire and explosion risk assessments, including hazardous area classification, identification and drawings, safe handling of combustible dusts, etc. We also offer an auditing service to our clients to cover such requirements as gap analysis of your site or process versus state-of-the-art best practice, ensuring regulatory compliance, either for modified plant or as an ongoing legal requirements, modification to your COMA reports to ensure ongoing compliance, We also offer a full suite of safety-related calculations, particular emergency relief covering relief devices and vent header design and consequence modelling using programs such as FAST. And we have an operational health and safety side where we provide occupational health and safety, including workplace risk assessments. So the key to our offering is our capability across all stages of a project life cycle, from an idea in its infancy to operational issues. It's particularly important to involve process safety from the very beginning to ensure that what we're designing is inherently safe. And we firmly believe that this will offer long-term cost savings and operational advantages to anyone. So I'd like to hand over to Rob now to go through some recent services we've provided for our cross-sector clients.
A major area where we get involved is with ATEX or DESIR compliance. We're often called into site in order to update existing ATEX assessments, or we may need to address ATEX aspects associated with a new project installation at an established manufacturing facility. We often encounter situations where blanket zoning has been adopted and where the basis for the hazardous area classification has not actually been defined. Also, we continue to see examples of hazardous area classification where the engineer has simply adopted the nice examples which used to be contained in the earlier versions of IEC 60079, and they simply apply this zoning philosophy across all applications. Now, this approach is overly conservative and entirely inappropriate and can result in significant and unnecessary capital expenditure and maintenance expenditure throughout the lifetime of the process. Some engineers are extremely conservative when performing area classification on a new facility. They seem to forget the #1 priority of the ATEX directive, which is to prevent the formation of a flammable atmosphere in the first instance. Now, it's important to understand that this is readily achievable with a new installation. If equipment and piping systems within a new installation are designed as durably technically tight, then there will be no secondary releases. Furthermore, for dust plants, if the widespread use of homemade flexible joints is avoided and a robust housekeeping regime is employed whereby any minor spillages which do occur are addressed within the shift, then no external dust zoning is required. There is potential for huge savings to be made. We perform process hazard analysis works for multiple clients. This can be new projects or a PHA review of an existing long-established plant. The breadth of in-house knowledge and experience gained across multiple sectors of industry and a detailed understanding of the current state-of-the-art technology help us, PM Group, to be both challenging and proportionate when we perform these studies. Now, there is a requirement to maintain ATEX and DESIR assessments current and up to date. There's also a similar maintenance requirement for the HAZOP. Now, this does not mean that a fresh report has to be generated each and every time that the review period comes up. Revalidation is recognized as an appropriate methodology to be used in order to detect system decay. Now, finally, on a somewhat lighter note, a few years ago, I was working on a site when an engineer dashed into the office and appeared to be in a bit of a panic. We've just found out that the powder we're charging into our process vessel is a combustible dust. Can you please tell us what testing to do, and as we need to get this done as a matter of urgency? Now, I asked him how many tons of powder they were using, how it was being conveyed to the vessel, and did the vessel contain a flammable solvent. He explained that they were using 3 kilograms only, and that the powder was being manually charged, and that the vessel contained water. Now, whilst he was reporting this information, I'd managed to find several entries in the Justice database which suggested that the powder was of low explosibility and with very high minimum ignition energy. So, in answer to the question about dust testing, I told him that he didn't need to do anything. And he was quite surprised by this. Now, in order to add relevant context to this discussion, I reminded him that it was the grand final of the Great British Bake Off that evening on television, and that there would be more combustible dust in the tent than he had in his entire process. He went away with a relieved expression on his face. Now, the moral of this is it helps a great deal when you know where to look for information and when you adopt a sensible risk-based approach. And finally, I'd like to say good luck to all of the process safety finalists. Thank you.
Thank you very much for your time.
Okay, thank you very much to Shona and Robert, and thank you to PM Group for sponsoring the IChemE Awards. If there are any questions for Shona and Robert, we'll pause for just a moment. You can type them into the questions box on GoToWebinar. While I give you a moment on that, don't forget, we're live tweeting throughout all of the IChemE 2020 Awards webinars. You can get involved using the hashtag IChemE Awards. Okay, we don't appear to have any questions, so thank you very much, Shona, Robert and PM Group. Before we move on to announce our finalists, I would like to remind you all about the IChemE Hazards 30 Process Safety Conference coming up next week. It's a virtual conference with more than 70 peer-reviewed process safety presentations. There's still time to register at icheme.org/hazards30. So without further ado, here are our finalists. We have ABB Energy Industries, Advanced Analysis Australia, Petronas Penipisan, winner of the IChemE Malaysia 2020 Process Safety Award, Renatech, Safety Solutions, and 3 entries from Saudi Aramco. All our finalists have been invited to join us today to give a short presentation on their work, and subject to time, we'll be inviting you to participate in Q&A at the end of each presentation. You can ask your questions via the questions box in the GoToWebinar portal. With that in mind, please welcome our first speaker, representing ABB Energy Industries. It's Carl Watson.
Hi everyone, this is Carl Watson from ABB. I'm a solution architect, part of the digital team here in ABB. I've been involved in process industries for over 30 years now, a long time of that involved in process safety, doing roles such as hazard studies, LOPA studies, and functional safety. As I say, now I'm in the digital arena. So what I'd like to do is, first of all, thanks to the IChemE and the PM Group for this opportunity to share with you a new digital solution called Augmented Field Procedures, which is really focused about reducing the opportunities for people to make mistakes in the field. Okay, so I'm just checking that you can see my screen okay?
Yes, we can, yes.
Wonderful. Okay, so augmented field procedures, what do we mean by procedures? There's lots of examples of procedures in the industries that we work in. So things that we're really focused on are things like standard operating procedures and maintenance procedures. So that's just to give a little bit of context of what we're talking about here. So we have procedures in our industries, but do people follow them? So there's a number of studies through the years that is actually indicating that people don't follow the procedures that we have in place. And the issue with that is things like this can happen. So we've got Bhopal, where there was too much emphasis put on procedures as a control measure. Piper Alpha, that is where people weren't actually following the process safety procedures. And then Texas City as well, not following, they were deemed to be inadequate as well. So that's some of the consequences of not following procedures. But it's not just safety related, there's also an impact in our operations there. So here's some more studies out there that have suggested that we're losing around about 5% of annual production due to unscheduled downtime, and around about a quarter of that unscheduled downtime is due to people making mistakes when executing procedures. So that's sort of just an introduction, and just to say that, well, hey, we have procedures. People are generally not following them, and there's some safety and operational impact because of that. So recognizing, certainly from the safety perspective, that needs to be addressed. A few years ago now, that in the UK, the Health and Safety Executive have produced a human factors roadmap, where we are looking to first of all identify the scenarios, the major accident hazards scenarios that have potential for human factors in them. We do a review of them, hopefully being able to, along the lines that the PM group have just said, become inherently safe, so I remove the opportunity for error. But where there's still a reliance on the persons to make some sort of some risk reduction measures, we then need to review that and ensure that the opportunity for that person to make a mistake is minimized. So that this process addresses, so any particular process should have three elements. Look at people, it should look at the process, and it also should look at technologies. So what we have here from the as part of this roadmap, we're addressing the first two of those. We're looking at the people and also the processes associated with the procedures. But unfortunately, what it doesn't do is look at the technology, or doesn't adopt technology. So if we take an existing procedure that runs through this process, ultimately we turn it back into a piece of paper and give it to the person that's always been doing it for the last, say, last 20 years. And we say, I know you know what you're doing, but we need you to do it this way to avoid making mistakes. So just the human nature of people from there is to say, hey, I know what I'm doing. So that new procedure, they will just roll up and put it into the overalls pocket and do it the same way. So therefore, by not adopting the technology or not introducing technology, we're actually losing out on the benefits that the human factors roadmap has introduced. So that leads us into the application that was part of our submission, which is ABB Ability Augmented Field Procedures, which is where we're taking the paper output from the human factors roadmap. We're digitalizing the procedure. One second, just put the pointer on. Digitalizing the procedure, then enabling that to be executed on a mobile device. We have an opportunity then to integrate that procedure if we've got the infrastructure in the field, so industrial Wi-Fi. We can connect the person in the field with the automation system, and we have then also adopted Microsoft HoloLens technology, which is future-proofing these applications. And I'll show you a video at the very end so you can see what that looks like in terms of executing the procedure. So what I'd like to do now is just to introduce just a few of the opportunities that the technology introduces in terms of reducing human error. So I'm just going to start off with in a sort of a disconnected mode, i.e. not connected to the automation system. So in terms of reducing human error, we've got a number of areas that exist. So or opportunities. Here we get two identical couplings, and there was an incident in the US where a tanker was connected to the wrong coupling, and the contents offloaded. The two materials were then incompatible, and we had a large toxic release due to all caused by the person connecting to the wrong device, wrong coupling. What we have now with the mobile technology, we can then use the camera on the mobile device to scan a barcode, a QR code, or object character recognition, or even device recognized devices to say, hey, you're about to connect to the wrong coupling. Don't proceed, connect to the other coupling. So that's how we can use the technology to introduce new error reducing measures. Another example is completion errors. So how many of people on the call here today have took a photocopy? The primary task is to take a copy. The secondary task is to get the original. So how many on the call have actually left the original under the lid of a photocopier? That is a completion error. So obviously very minor consequences to that. But if you're in an aeroplane and you look out the window and someone has done some maintenance as a primary task on the aeroplane engine, but the secondary task was to fix down the cowling, you'd be very concerned. If you then start to take that a little bit further, some high consequence errors here in the UK, the largest peacetime explosion in Europe at the Buncefield storage depot. Some of the contributing factors to that were completion errors. So here at the top of that storage tank that overfilled was a level switch. For the level switch to function correctly, we needed this padlock in. But due to maintenance, the maintenance was performed, but in a number of the storage tanks, this padlock was not fitted. So how does our technology help us? Well, we can start to use an as left and an ideal situation to do comparison. So in this instance, we can see that the padlock isn't fitted. We can compare it against the ideal situation, fit the padlock, and we can avoid that largest peacetime explosion in Europe. So if we take a little bit further and start to look at the connectivity. So now this is the person in the field is now through industrial Wi-Fi on his tablet device able to see information from the control system. So how does that help us? Well, here there's an efficiency piece. So immediately the step is to control to record the tank temperature. So we don't need to call the control room and get that temperature. We have it automatically on our mobile device. So that's one scenario. A second scenario here is where we have to wait for the temperature to drop below a certain temperature, which is only available in the automation system before we start a timer. Now the person in the field can start to see the temperature dropping, doesn't need to keep calling back to the control room to check if the temperatures is down to below 50 degrees C. If you think about the scenario where the person in the control room is very busy, the person in the field may not be getting a response. That person in the field may then decide that actually it must be below temperature now and then proceeds with the procedure. Then there's potential for errors in that. So now by having that information available, we can interlock and not proceed any further until it is below the temperature. Another thing that we get to do once we digitalize procedures, here we have some software that looks at batch execution. So each one of these is a batch execution and how well it's been performed. If you think of procedure, it's like a batch. So therefore, we can now start to have timestamps for every step that execution. So we can then start to lead towards looking at different KPIs for procedures and identify what's the golden procedure or the right way to execute that procedure. We can then compare people. So if one person executes it in 5 minutes, another person takes 7, we can say, well, why are you take so long? It may be that they need training. So when we can introduce training, or it may be that person takes a little bit longer, they do extra steps that's not in the procedure. And that's a key here about containing corporate knowledge. Trevor Kletz, a famous safety guru, has used the term organizations don't have memory, it's the people that have memory. So when that person that does extra steps leaves the business, the company, that knowledge goes with them. So it's key that we take that knowledge and embed it back into our procedures. Last PC, which I just talked about at the start, was future-proofing, because the people still, when they go in the field, they still, rather than having to carry a clipboard with them, they have to carry a mobile device. I just want to show you the new technology called Microsoft HoloLens. It's augmented reality, so you see the real reality as well as additional information on top of the reality. And the key here is once the technology improves and becomes a little less cumbersome than what it is at the moment, it becomes hands-free. So you'll be just like walking through with your light eye protection at the moment. This is where we'll get to. You'll be able to have this information available. So a little short video. It's from a trade show that we did. We didn't have a real facility there, so we used a Lego model, but I'll just show let this video play a little bit and you hopefully can see. So what you can be able to see at the moment is that this is the procedure. And you can interact with it and you can see the background here. So you can see a colleague of mine just walking past. Here's the step. And now I can look at the facility and I can see the information from the DCS superimposed onto the facility. So therefore I know without having to call to the control room to get the tank temperature. So we can then enter that and interact with it. we can then go on to the next one, which is wait for 10 seconds for recirculation. If that's 4 hours and you've been recirculating for 2 hours and you're in a rush, you've got somewhere to get to, you're coming to the end of the shift, we'll say, okay, that must be long enough, but it's actually 4 hours for a reason. Another step now is to wait for 50 seconds. Now, sorry, wait until the temperature is below 50 degrees C. And then what we can see here now is we're in the field, we're fully informed, we can see the temperature dropping and we cannot move forward with the procedure until that temperature drops. So as I say, now as a field worker, I'm fully informed with all the information that I need to execute the procedure, and I don't need to keep calling back to the control room and avoid the risk of not getting the right information to allow me to do the right task correctly. And that's all. That's what I'd like to show you, just as an introduction to the new product that we've launched during this year.
Okay, thank you very much, Carl. We'll now pause for questions. So if you have a question about what you've just seen, please type it into the questions box on GoToWebinar. While I'll give you a moment on that, let me remind you that this is one of the series of IChemE Global Award webinars taking place this month. We've still got several more webinars to come this week. We wrap up on Thursday. If you'd like to find out more about what's still to come, please visit icheme.org/global awards. Okay, we have our first question. How well accepted is the handheld device by field operators? Do they see the advantages outweighing the big brother is watching you downsides?
I think it's a great question and something that needs to be handled sensitively. And there's the carrot to it is, now I've come from an operating background, and I've been in the field with a piece of paper when it's raining and my pencil goes through the paper. I have to write everything down, then come back into the control room and manually transfer that data that's difficult to read. So we, rather than a big brother angle, we try and take a more positive angle to it, to say, hey, this will really dramatically make your life easier by automatically capturing the data and avoiding that extra work, if you like, to transfer the data. So that's one side of it. Second side of it, as if we really want to attract the good people into our and maintain our workforce, do we really want to, especially with the new generation that are coming through that are really happy with using mobile technology, do we really want to ask them to go to the field and record it in paper? Especially if that's your company and another company down the road says, hey, we've got all this technology, who will that young people want to come and work for? So that they're the sort of the positive angles that we should adopt with this, rather than the big brother side.
Okay, thank you very much, Carl. It's time to move on. So thank you for your presentation.
Thank you very much.
Next up, representing Advanced Analysis Australia, please welcome Madat Abdel Jawad.
Hello, let me just switch on my camera, share my webcam. Can everybody see my screen now?
Yes, we can.
Okay, all right, well, hi, my name is Madat Abdel Jawad. My talk today is called exploCFD. It's a revolution in consequence analysis. Now, traditionally, there have been two distinct methods for modeling the consequences from an explosion, whether it is a BLEVE or a gas explosion or a dust explosion, or something like the ammonium nitrate explosion that we saw in Beirut earlier this year. The approach has either been to model it using an analytical method, or I'm sorry, my screen is gone. An analytical method, or which is what you should see on the left, or CFD. Now, the analytical methods are things like the guideline for the application of the multi-energy method, GAME, MEM, the TNT equivalents. These are one-dimensional methods that result in typically concentric type circles and are typically superimposed on top of a 2D plot plan. So sometimes they're called 2D methods, but in fact they're radial, they're 1D. And of course, alternatively, you've got CFD, which is computational fluid dynamics. Now this captures the interaction of obstacles with the flow, and therefore more accurately depicts the directionality of the explosion. For one thing, in gas explosions, it's been argued by many for many years, including myself, that the flame acceleration process is it cannot be captured except using CFD, and I'll show you why that this is no longer the case as we progress in this talk. But still, the analytical method is far more popular than it should be, given the advantages that that CFD has. And you know, partly it's the well-known cause of CFD being more expensive and more time-consuming, more cumbersome. But it's actually, there's more than that. With three-dimensional CFD, there are still uncertainties. Not a lot of people talk about them. For example, in chemical reactions, the chemical reactions, well, they should be for an explosion, which has typically or often has the flow residence time and the reaction time of the same order, what we call a Dam-Kohler number equal to approximately unity. The chemical reactions should be modeled explicitly using something like an Arrhenius reaction rate, a pre-exponential multiplier times the exponent of some constant on RT, which is different for every reaction. But this is not possible at the moment. Instead, lookup tables are being used because even for the simplest hydrocarbon, we're talking about 100 reactions for the combustion of, say, something like methane. And so you're going to have to solve these at each and every time step. And so instead of solving 4 equations, now you have to solve 104. Other uncertainties arise from turbulence models, even uncertainty in the input. Now, you know, imagine trying to find the gas cloud size, location, composition arising from a release, a loss of containment. The best you could do is do another CFD model on the release. And you would do perhaps a multitude of simulations, but each one of them would be at a constant wind speed with a constant wind direction, perhaps with a statistical noise model added to it. But that doesn't capture neither the infinite combinations nor the significant effect of a fluctuating wind. And we know from experiments that this has a massive effect on explosions because it has a massive effect on the size of the flammable gas cloud. There are others. This is, you know, just a snapshot due to time. But bottom line, you're really looking at maybe 30%, 50% uncertainty at best for the state-of-the-art CFD for an explosion. There's also been positive developments with analytical methods. In 2010, for example, my then PhD student, now Dr. Jingdi Li, showed that the CSC correlation, confinement-specific correlation, has excellent agreement with CFD. Now, this was for gas explosions, which surprised a lot of people because it had long been argued, including by myself, that flame acceleration requires the explicit modeling of obstacles. But nevertheless, the R squared here for over 3,500 cases, you're looking at 1,500 of them, was about 84%. And this gave rise to hybrid methods. Now, hybrid methods are aimed at you know, quickly calculating the explosion consequence within the uncertainty of the best that you can do. So it takes the inputs, calculates the source of the explosion pressure using a good analytical method, perhaps a Prue method for BLEVI, a CSC method for gas explosions, and others. And then that's fed into a CFD model, which the CFD solver is a 3D solver, but it's configured as a 2-dimensional solver so that it runs faster. Now, you know, this is not suitable for every single case, but in many cases, the 2-dimensional solution is adequate and if a little bit conservative. Now you need that conservatism given the uncertainties that we spoke about earlier. And then after the CFD calculates the propagation of that pressure into the wider domain, the output is visualized. To make matters easier, we have developed another innovation which allows the software to read just a simple PDF of a plot plan or an elevation drawing that's useful in offshore, and convert it into a domain in which converted basically into the grid where the process is taking place. One of the first things that we did, and I saw Carl talking about Bunsfield, one of the largest explosions in the world. Now, the key thing about Bunsfield was the two streets, which are this gap here, represented by the gap here, 3 Cherry Trees Lane and Bunsfield Lane. And this is our model of the flame acceleration that took place in Bunsfield Lane, resulting in overpressures that were very, very similar to that which were done by the investigating company at the time, Flaxen experiments later on. And in fact, you can see here the reflection of the shock wave off the buildings. If I take this back, you could see the reflection of the shock wave off the buildings, off the tanks. And this is something that you rarely find in other software packages because the entire domain is typically converted into a large porous medium. Here's another reflection coming up off this tank, into a large porous medium rather than modeling the obstacles separately. exploCFD is also being used to model cases like this one. And this actual, I'm going to speed this up a little bit because of the time, but basically this goes through the entire process of loading the drawing, selecting the lines that you have. I'll just pause it here for a minute. This particular issue was a floating regasification and storage unit that was off the coast of Rio Grande do Sul, which is the southernmost state in Brazil. And there was a residential area here called Vila Mangueira, which the regulator was concerned about. Previous analytical calculations had shown that perhaps the Vila Mangueira was going to be affected by an explosion on the FSRU. And what was needed was a quick calculation because the regulator had withdrawn license to operate. So this goes through the procedure, but basically what you get is a conservative estimate of the explosion, which is needed in this case, but that also showed that Vila Mangueira is not affected adversely by this explosion. exploCFD is being used for ammonium nitrate explosions. This is a case of an ammonium nitrate explosion that took or that is being modeled as a what-if scenario in a large ammonium nitrate manufacturer. Large quantities of that. The results are in agreement with previous studies that were carried out using 3D CFD. And this is an interesting one. This is a case that we did in maybe 1 hour, a couple of days after the event of Beirut. What we did was we took we vectorized a map of the city and calculated the source charge of the explosion based on the size of the crater that was left behind from satellite photos. This is typically what's done in accident investigations, which is something that we also do. So we were quickly able to calculate the explosion taking place, not just the asymmetry of the explosion or the propagation of the overpressure, but the pressures seem to match the damage on both sides of the major road, which is the Charles Helou Road, separating the industrial port area from the residential area. And that was carried out very quickly. And this is the power of something like a hybrid method. Blevies, it's being used around the world for blevies. This is an example of one of the cases one of our clients had carried out. It's an explosion of a blevy, and the result is obviously they were concerned about offices, manned offices that were next to the tank or in the line of sight of the tank, as it were. The beauty of this method is that the tool chain components have, already been heavily validated. But the last 2 years, we've spent a lot of effort validating the entire chain, and we continue. Of course, this is an ongoing process. I think a couple of weeks ago, we just had a paper come out in Process Safety Progress on another BLEVI case, and pretty soon we'll have another gas explosion validation case in the NAFEM's International Journal of CFD Case Studies. It's growing fast. Hybrid methods are growing fast and will be an important method for consequence analysis in the future. I've got a lot more to add, but I was told that it was supposed to be within 10 minutes. So hopefully, if you have questions, I've got more slides and videos and things to show for whoever's interested. Thank you.
Okay, thank you very much. So once again, we will pause for questions. So if you have a question, please type it into the questions box now. And while we wait for questions, now is a good time to thank our volunteer judging panel, led by head judge Keith Batchelor. The judges work tirelessly to review and score every entry across all of our categories. You can find out more about their work and the judging panel on the IChemE Global Awards web pages. Right, we don't appear to have any questions, so thank you very much. We will move on to our next presentation, our third finalist. From Petronas Penipizan, please welcome Akmal bin Anar Bacha.
Yeah, can you guys see us?
Yes, we can see you, yes.
Okay, Assalamualaikum, very good evening from Malaysia. My name is Akmal, it's my colleague.
Hello, good morning everybody. And then I'm Kor, one of his colleagues.
So we are from Petronas Penapisan Terengganu, one of the oldest refineries, Petronas refineries in Malaysia. So we process crude oil and condensates. So one of the daily activities here in the process plant, and we are in a plant, by the way, it's just that we decided to dress a bit differently for the occasion. One of our big tasks daily is to collect samples. So we have sampling bombs, and the issue that we found was that a lot of our sampling bombs, the needle valves at the end of the bombs were getting loose. So it was hard for us to contain samples, and it also presented us with a couple of other problems. For example, that we had to take time to send the sampling bombs to maintenance to get them fixed. There was time taken in sampling. Instead of taking a sample for 10 minutes, we would be taking longer because the operators would find it hard to tighten the valves. And so, and our creation, this is what we call the smart ratchet. And in a moment, I'll pass it over to my colleague Kor, because he's really the brains behind this invention. But we are really very happy to be presenting. Normally, I told my boss we would be taking a flight to the UK for this, but instead it's just a flight to the meeting room. So without further ado, I'll pass it over to Kor, if you please.
Okay, hello once again. So as you can see, this gadget in my hands is called the Smart Ratchet, and then it's actually made up of two parts. So actually you can see this is the socket part, and this is where people will hold it. It's the handles where we increase the grip with some rubberized tips over here. So actually this thing works by fixing this socket into the needle valves. It's actually custom made. You can actually just interchange it, change it out for a bigger socket, or use it on a smaller needle valve if you want. And then as you can see, if you guys can see, there's this little knob on here which allows us to switch to clockwise or anti-clockwise operation of this valve, so that we do not over tighten or mis-tighten it in the different direction when we are tightening the needle valves on the sample bombs. Besides that, the main reason we make these smart ratchets is because that we are an aromatics plant. So there's benzene, we produce benzene, so we do sample benzene. So when doing sampling of benzene, we have to wear very thick rubber gloves because protect our operators from these hazardous chemicals. So when the operators are wearing these really heavy duty gloves, they really may face problems. They fumble when they want to tighten these really small needle valves. So with this gadget, the smart ratchet, they can actually easily hold these two handles and just tighten it very easily. And then another problem arises when they sort of like kind of destroy the needle valves when they can't like usually use the fingers. They will try to use tools. Like the best as alternatives is usually the pipe wrench, where they will just like tighten it on it and then just rotate the pipe wrench, which is sometimes is the main reason for the needle valve to get defects and problems, because the whole rotation actually breaks the spirals inside the needle valves. So I think that's my main explanation on this smart ratchet. I'll pass it back to Akmal for.
Yeah, thank you so much, Cor. So we saw the value in trying to solve a problem which is faced by most of us on a daily basis. So we thought that if we could solve the problem of sampling, that would represent something which has a bit of a lower barrier. But if you can solve the problem well, the potential benefits towards sampling time, towards maintenance time, was significant. I would also like to add that this idea came from our field operators mostly. So it's something that they face on a regular basis in their day-to-day job. The idea came from them. Really, they were the backbone of their project. So so during these times, we would just like to pay tribute to our operators to keep the plant running safely and efficiently. So a lot of that project and most of our projects here in this plant, we are not new to the innovation comms, IChemE, and the other comms that we join. It's a team effort, really. So that's just a little bit from me and Cor. So if you have any questions, feel free to fire away. Thank you.
Thank you.
Okay, thank you very much. So once again, we'll pause for questions. If you have a question, please type it into the questions box now. And whilst I give you a moment on that, don't forget the winner of this award will automatically qualify as a finalist for our top prize, the Outstanding Achievement in Chemical and Process Engineering Award. We'll be announcing the winner of that award on Thursday afternoon. Why not join us for that webinar? It's free to attend and open to all. You can register at icheme.org/global awards. Right, we don't appear to have any questions, so thank you very much. We're going to move on now. And next up is Emily Tirritt-Jones from Renatech.
Hello, my name's Emily Tirritt-Jones, and first of all, I'd like to thank IChemE for this opportunity to present on this topic and give you first of all, a little bit of an introduction to who RENA is. So RENA is a global company in over 75 countries around the world. And I'm part of the product regulatory compliance team. So this is a team based in the UK, although as a company we have a high kind of presence in Italy. And as a team, we support manufacturers, importers or distributors of engineering products, as well as regulators such as the European Commission or national authorities, to try and make sure that products and chemicals are meeting their technical and environmental legislation. So unlike some of the presentations you've heard this far, then this has a slightly different approach of how to approach safety, as there's many drivers to it always. And this is kind of taking the approach where it's driven by legislative requirements. So a bit on the piece of regulation that has driven our innovation and development in this area. So the piece of legislation which I'd like to talk to you about today is called the REACH regulation. So it's a piece of EU chemical legislation to do with chemicals and substances, as well as articles. So these are typical products that you can hold and most companies tend to make. So this is the most complex bit of environmental legislation there has been in the EU thus far, and generally has a large impact on all companies across the EU, and there are many equivalents that are either under development or developing in many other kind of global areas. So even though this is a kind of a EU focused approach, there are equivalents. So because the REACH regulation is quite complex and has many different obligations, as a piece of legislation, it's over 500 pages with the associated guidance on top of that. So it does mean that lots of companies don't know how to meet these obligations and ensure that the products that they are producing are safe as well as compliant. So although the regulation does have many different requirements, what I'd like to talk about is one of the specific obligations under this. So the obligation means that if a article or kind of a product contains a substance of very high concern, then you need to make sure that the recipient of that article knows about that substance in them and is provided the information for safe use of that article. And this is kind of an obligation which many struggle with, as it kind of drives down to a high degree of information requirement. So substances of very high concern are classified by the European Chemicals Agency and are carcinogenic, mutagenic or radioactive substances. And although they often have very good engineering reasons that they're contained within articles, generally are not pleasant things, and as part of the way that legislation tries to influence positive change and moving to safer alternatives, part of one of the vehicles to drive that positive change is the REACH regulation and making sure that people are using these articles know that they're contained within it. So speaking a little bit about kind of how firstly companies have developed ways of complying to this requirement, and then secondly moving on to how RENA offers kind of an alternative way, a developed kind of methodology about how to meet this requirement in the most effective way. So that there are a range of options, and it's a kind of a spectrum of how you can demonstrate compliance to this requirement. So on one far end of the spectrum and on the left-hand side of the slide, there's quite a passive approach. So the way that you get this information is that obviously as you build up more and more complex articles, so from the building up of kind of an O-ring to a valve to a pipe system to a complex product, then it means that each level of the supply chain needs to communicate this information, and you can have a quite passive approach to this, so you rely on your suppliers to pass on this requirement and that everyone is equally aware of this requirement and has detailed information, and is then reliant on everyone understanding that the same level of requirement and same level of information. Where this gets quite complicated is often supply chains now are global, and this is obviously an EU-driven requirement, so people's knowledge of requirements is different in differing areas, as well as if you're using a kind of small to medium-sized company, obviously there is specialist knowledge sometimes in this. So having that as an obligation puts a lot of pressure on suppliers to kind of meet this requirement and make sure that the correct kind of safety information is communicated across the whole supply chain. Then on the other end of the spectrum is about kind of taking the middle approach. So this is kind of making sure that each company undertakes more kind of personal responsibility to make sure that the data is requested. So you have to report on substances of very high concern, and currently there are over 200 substances and more are continuously added. So if a company chooses to make communications to the full supply chain, it means that it's a lot of paperwork. It creates a quite difficult route to demonstrate that everyone has responded, and generally means that there is a quite low response rate of around 30% or sometimes even less, depending on the specific supply chain, and means that the overall confidence in making sure that you have the relevant information so you can safely use products isn't really there. So the other way that companies can tackle this is, in the second part of this middle box, is around component testing. So you can undertake tests to see if a SVHC is contained within an article. Obviously, there are quite a number of them, of over 200 SVHCs, and some of them require specialised testing to find that. It's obviously costly and time consuming, and generally all products can't be tested just due to the timeframes and cost associated with that. So because the communication of this information is not only important for a regulatory standpoint, but also the safety standpoint, RENA has developed a kind of methodology to enable kind of a focus request, this far right-hand box. So we have developed a way of assessing which SVHCs are most likely to be contained within products, and I'll go a little bit more into how that's been assessed in the next slide. But effectively, this means that there is a much lesser kind of cost associated with this information, because either communications or even testing, if a company wants to take that approach, means that you get a lot higher quality data, because you aren't undertaking a blanket approach but a focus request or testing. It means that your confidence in the data and then the actions that you can undertake about them is a lot higher. We've also found that because often these blanket data requests are quite expensive, that lots of companies obviously have a limited budget. Everyone needs to be commercially sensitive, and that often that the money which would have been spent on these blanket requests is often refocused on finding safe alternatives and research and development activities. In part, that also does tie back to the confidence of knowing that all of your SVHCs have been identified, means that commitment to finding alternatives is also reinforced as a business. So it has this short-term reduction in cost, but also the longer-term view of finding safe alternatives, which really is a very large driver in a lot of businesses. So, as I said in the previous slide, the way that the list of SVHCs are determined is on a likelihood basis. So the way that is probably easiest to conceptualize is this kind of concentric circle diagram. And it effectively gives a risk rating of what substances, rather than considering all 200 in all part types, which ones are likely to be used or potentially used. And that really does mean quite a foreshortening of all of the requirements, and definitely allows a kind of a positive approach. And the way that we've made this kind of down selection and risk review of each of these substances is from 4 key themes of information. So as the REACH regulation, but many other regulations and industry trends, different chemicals go in and out of kind of popularity, almost, about which ones are more used. And that can be driven by legislative changes. It can be driven by technological changes, or of other safe alternatives are found. But it does mean that the predominance of certain substances changes, and we monitor that as a company. Of course, there is an underlying chemical property. So certain substances are used as plasticizers in rubbers and plastics, and the inherent properties of those chemicals will never change. So it means that for some part types, it is highly unlikely or not at all that the substance will be used. Some substances are also not contained in the final article, so they are either consumed or not part of the article, so they are used as process chemicals only, so don't influence the people who are handling the article or product when you're passing on to the next person in the supply chain. The third kind of theme is around kind of the information that's made publicly available. So a lot of national bodies and trade associations undertake a lot of monitoring activities to make sure that these requirements are met, and they obviously publish different results. And then the fourth and final way that we consider when we're assigning a kind of likelihood is that RENA have labs that we undertake testing on behalf of different clients to undertake the testing that was originally referenced about the SVHCs. So between all those kind of themes of information, it allows quite a high degree of down selection of which ones are useful. So the benefit of this is that obviously the more complex the product at the end of it, the more levels that the supply chain has to go down. And we've spoken about the different challenges different suppliers might face in gathering this information in the first place. But it does mean that this information is gathered a lot more quickly and cost effectively. So from that, there are a lot of kind of changes which we've seen companies make, and definitely means that the idea of kind of the circular economy and making sure that products are used safely whilst they are in use, but also allowing the transition away from these more hazardous substances because of the allowance to find safer alternatives, means that the products which we are helping with are becoming safer to use short term, but also allowing more activities that when they come to the end of life, that they are more able to be recycled and reused, because these substances are very high concern, are slowly being transitioned out through this process, allowing this kind of a lot more continual use of the products, which I think is an aim that we can all very much get behind. So on that note, it is a very kind of quick overview on our approach that we've developed and the reasons why we think it has a positive benefit to many different companies and the kind of wider circular economy kind of effects. And at this point, I'd like to say thank you very much for your attention and open up to any questions.
Right, thank you very much, Emily. So once again, we pause for questions. If you have one, please type it into the questions box. I'll give you a moment on that. If you've been suitably inspired by what you've seen today to submit your own entry to next year's IChemE Global Awards, keep an eye on our website for entry information. We typically open for entries at the start of March every year. If you head over to icheme.org/global awards, you can check out the categories and the entry criteria. Okay, we don't seem to have any questions, Emily, so we'll move on. Thank you very much. Next up is safety solutions. So please welcome Paul Felto. Hi, Paul. Don't forget to unmute. You don't appear to be unmuted yet.
Hello, can everybody see my screen?
We can now, yes. We can hear you and
Yes.
we can see your screen.
Nice. All right. Okay. Hi, my name is Paul Felto. I'm the MD. I live in New Zealand. So good morning or good evening to everybody around the world. It's an interesting time of the day for me. I think it's about midnight now. I'll be presenting to you all on our process safety e-learning development project that we've done in the last few years. So welcome, and let's get into it.
Sorry to interrupt, Paul. You've muted yourself at this point again. We can't hear you.
Okay, I'm not sure what happened there. So, all right, so just a bit of background around myself. So, Safety Solutions was formed in 1993. We're based in New Zealand, and we now have offices in both New Zealand and Australia in a few locations. We have a few sort of good backgrounds. We've sort of helped popularize a few process safety techniques around the Australasian region, and we've trained over 3,000 people. So training is really a major focus of what we do, and we believe that it's a key mechanism to drive process safety improvement. And that's the reason we're involved in the training business. We have several popular courses, and this presentation focuses on our recent e-learning developments in this space. We believe that to turn the dial on process safety performance, the full organization needs to develop competence. And to me, that's the core of things. This is an idea promoted by IChemE, the ISC, and other organizations. My observation is that the corporate world has done very well in educating the focal points and evangelists in this space. However, there's still a large gap when it comes to the broader organization, including frontline staff, and these are the people that are most exposed to potential events. Having run a training business for the last 15 years, my observation is that the costs and logistics of face-to-face training remain a barrier to achieve organizational competence. To address this challenge, our vision is that competency development should be built on a common baseline. This develops an understanding amongst staff of the language and the goals. Once this baseline is developed, then specific training courses can be developed to groups such as executives, engineers, and operators, and these can be layered on top of the baseline training. Other aspects of our vision include achieving widespread use within an organization, incorporating adult learning principles, and enabled blending training opportunities where e-learning and face-to-face learning come together. Two areas of PSM competence improvement have been targeted as part of this project. Firstly, developing a core goal that I see in industry is developing a core understanding of process safety across a whole organization is a critical objective. If we can do this, we can facilitate better behaviors and actions across all staff. And the second objective of this project was to assist in developing quality hazard reviews, HAZOPs, and safety assessments by ensuring that our team members within the review are better understand their roles and they can contribute to the high quality review. So how do we sort of compare face-to-face training and e-learning? So we strongly believe that face-to-face training has its place. However, to address the challenges and vision, we feel that e-learning can help bridge this gap. Face-to-face training has its strengths associated with having the trainer and the trainees in the same room. However, e-learning enables scale, corporate management, and bespoke versions and messages to be delivered. We've developed two e-learning courses. One is called the Introduction to Process Safety, and the other is HAZOP Participants. The Introduction to Process Safety course is aimed at the whole organization as taught through a Plan, Do, Check, Act PSM model. The content is interactive, includes assessments, and is self-paced. There are 6 to 8 hours of content, and trainees get a full appreciation how their role fits into PSM. Our second course is called HAZOP Participants. It also takes 6 to 8 hours. However, it is focused on the HAZOP process and features a simulated HAZOP room where participants, minutes, and drawings interact. This project received some national R&D funding and was approved as a qualification mechanism to national competency standards. So that's something we're quite proud of. So how did the project work? So e-learning projects take a bit of a different route compared to capital projects. The effort of a successful e-learning project doesn't give you much short change out of 1,000 hours. So that the process that you see on that screen there took roughly 1,000 hours per course. The projects were executed through a specific development process which featured storyboarding, testing with clients, and online deployment. The effort leveraged our portfolio of face-to-face courses, and it's important to note that the feedback loop was critical to ensure continuous improvement. The online use of e-learning courses can either be through what we call a public learning management system, known as an LMS, or a private corporate one. The public edition features standard e-commerce functionality and receives regular updates in the self-service. The corporate LMS, learning management system, can be embedded into a company, and we can deploy our e-learning into the company network directly. So really sort of getting towards the end of the presentation. So after implementing the project, the following benefits were verified. There was a willingness to train the whole organization. We had a number of clients that felt that they were going to train all the operators and maintenance fitters and really sort of upskill them significantly. We now have incorporated e-learning into our face-to-face training, which delivers a unique blended delivery model where the e-learning and the face-to-face delivery coexist at the same time. So just to sort of conclude, was it easy? Was it an easy project? No, it wasn't. The investment was over 1,000 hours per course, not a small undertaking. Did we deliver on the vision? We think so. Feedback from corporates, universities, and regulators has all been good. Will we continue down this path? Absolutely. We will deliver a new course in the coming year. Have we made a difference? Time will tell. However, we're confident we're on the right path. Thank you, everybody. Happy to take some questions now.
Okay, thank you very much, Paul. So once again, it's time for Q&A. If you have a question, please type it into the questions box. While we give you a moment on that, particularly for latecomers today, let me quickly remind you about our annual process safety conference, Hazards, which takes place next week. It's a virtual conference and there's still time to register to attend. You can check out the program on our website, IChemE.org/hazards30. Okay, we don't appear to have any questions for Paul, so thank you very much. We're going to move on to our next presenter, and we have 3 presentations coming up from Saudi Aramco. First up, please welcome Banu Madala and Khaled Amoudi.
Good day all. Are you able to see my presentation?
Yes, we are, and we can see you too.
Oh, thank you very much. Let me thank you, organizers and the sponsor, for arranging such a beautiful event, for bringing together all the professionals onto the same platform and share their experiences in our journey for a safe and healthy world. I am Banu Madala, and with me is my junior partner and specialist Khalid Amodi. Let me introduce Mr. Amodi. He has 7 years experience and is a chemical engineer and is a certified EFQM assessor, a King Abdulaziz Quality Award assessor, and is also recognized operational excellence assessor. And he co-piloted a new technology in the Aramco, and which was accepted and adopted by many other departments. He is a recognized innovator and a certified risk administrator. And I am Banu Madala, and I have 32 years of refinery experience, including 13 years in Yanbu Refinery, Saudi Aramco, as well as in Qatar Petroleum and Hindustan Petroleum Corporation Limited. I'm a chemical engineer with MBA and a certified energy manager from Association of Energy Engineers. And I'm a certified Lean Six Sigma black belt holder. And I'm recognized by Saudi Aramco Board of Engineers twice. I won several international awards, as you can see here, from Association of Energy Engineers, UK Energy Institute, and also MIAS, and several other international awards. And it's a pride to be part of this seminar also today. And also I have piloted this new technology. I'm also recognized as a corporate innovator internationally, and I'm a certified agile leader and a FQM assessor and a risk root cause analysis specialist, and I'm also a risk administrator for the refinery. And today, outlook of my refinery, I will just share a brief on the Yanbu refinery and how we are integrating operational excellence processes in our journey to safe operations and a sustainable And I will present two case studies, how we are converting process safety challenges into opportunities innovatively. One is related with the instrument system, other is related with the fuel oil tanks, heating system, and I will conclude with summary. Yambu refinery was established in 1979. It's a hydroskimming refinery. It supplies mostly domestic refinery products, and it has 19 ISO certifications. To date, it has 21 international awards. Yambu refinery vision is to be a role model supplier of high quality refined products by 2022 and produce these high refined products with high quality, with highest safety and environmental standards. As you can see on the right here, the crude is about 250 MBD, 250,000 barrels per day refining. After the desalting goes through heaters and crude unit, and then we have it splits into the several products. The main key products are LPG, naphtha, which is blended into gasoline, and we have hydrotreaters, and then catalytic and reformer, and then also we have diesel hydrotreater, sulfur recovery unit, and a sulfur producing unit, and we produce high diesel, low sulfur diesel, which we are now converting into ultra low sulfur diesel also. And another product is fuel oil, which partly we send it to lubricate. And the refinery has been continuously exploring opportunities to develop, and has been started with 170 MBD capacity, then it increased to 250, then it is also added with fixed bed is changed to continuous bed in the reformer, and also we added DHT complex. And our goals, principal values are citizenship, safety, accountability, excellence, and integrity. Let me share a thought on the integration of operational excellence processes. As my previous author has explained, it's basically built on PDCA, operational excellence, plan, do, check, act, and also it is the process is developed on the ISO 31000, the 6-step enterprise risk management, and it shows how we are successfully integrating several processes through our operational excellence, which includes vision and mission strategies, management of change, and risk management, and innovation and technology deployment, and root cause analysis. This integration will help is that we will produce solutions which are thoroughly evaluated for the change and implemented with all the necessary precautions so that we have a safe and sustainable operations. And as you can see, we have followed the MOC for new and modern changes, and all these changes are now integrated through IMAM. It is an integrated manufacturing operations management platform where you can see here all the safety dashboard as well as management of change, risk management, so that all the employees of are aligned to meet the corporate objectives and departmental objectives to be a safe and sustainable operations. Let me tell you how the two case studies, as mentioned, we are conducting hijab studies, revalidation studies, so that we could to identify the risks or any changes. So we're continuously evaluating those risks, monitor and evaluate. In those hijab study, we have identified two risk-prone areas, which is one of them is the instruments malfunction from poor quality of instrument air and an unreliable instrument air supply with single source of cooling water and high cooling water temperatures. Let me explain you here is earlier we have only two compressors. So in case of any T&I, one compressor goes down, then we have to bring the portable compressors to support the system. The portable compressors will not have all the features and has potential human errors introduction. So which can cause high moisture or even delays. So it can cause a potential instrument error interruption and emergency shutdowns. Actually, to replace these three instrument compressors, we need to have a new compressor. And so I will highlight how this system has multiple risks in the subsequent slides. Another is human intervention risks for fuel oil tanks integrity, how this fuel oil tanks heating coils, how this is affecting the refinery or the process safety, and how we converted this into opportunities. We will see in the subsequent slides. As you can see, instrument air system is very essential. It's like a nervous network of the body, similar to the plant operation. Any instrument changes in the instrument air, either quality or quantity, can affect the refinery operations. As you can see, high moisture can impact instruments negatively. If the moisture in the air, if it is not removed, then if it carries over to the system, then it can produce corrosion products, and the plant air and instrument air transport lines can also get corroded, or the equipments cannot get the required instrument air pressure. As you can see, normally the instrument air system is like the air comes from the atmosphere, is compressed, and in between the compression, it goes for the coolers so that the compression will be effective, because otherwise the volume expansion will be very high. That high temperatures cannot, it requires huge power to compress it. Ideally, the system is like that after the compression, because 80% of the heat goes in, energy goes into the heat of the air. So if the hotter air then goes to subsequent stages, it is difficult to sustain even the metallurgy of the compressors, or even it trips. That's the reason we have interstage coolers, thus to bring back to the temperature as near as possible to the ambient, or to the atmosphere, to slightly more than that. Otherwise, it will go to 60, 18, 90, 120 degrees. Then it will cause a trip or the compressor's integrity damage. Earlier, we have a tempered water cooling system which goes through these coolers and return back. But as I mentioned earlier, the crude unit has been expanded, so this has increased the load on this system. So the tempered water system itself is becoming hotter, especially in the summer, and in case of any cooling water problems in the system. So what is happening is this is bringing down those efficiencies and bringing the risks. Moreover, these instrument air compressors should have two sources of supply. What will happen, why it is required is, any interruption in the cooling water supply, it will cause this compressors to trip, and then because of low boil temperature as well as high air temperature, so to protect the compressor. So in such cases, in case of any instrument air trip, it will shut down the plants. It's an emergency shutdown which can cause thermal shocks to the equipment. So how to mitigate this? I will show you in a tool. Actually, we need to provide two sources. So in case of a high temperature, or in case of a trip of this tempered water system, I can provide supply from the another source. If this is not properly maintained, then even the dryers the desiccants will get saturated. The dryer in the cannot remove the moisture, so the air going to the system will be with high moisture. So this has potential to bring human interventions frequently to mitigate, to avoid these compressor trips. As we know that human interventions always has a potential to cause some risks in the system. And as I mentioned, this backup cooling water has to be lacking of it as another threat, while it is affecting KPIs as water use and bill and reliability of the equipment. So it requires a high capital to upgrade the whole system. The tempered water system has to be upgraded, which is 1.5 kilometers far from the utilities, and the supply header as well as fin fans. As we said, as the existing compressors are not enough to me getting the cooling water, and we need to procure another compressor, so it becomes very, very high capital intensive. Now what did we do? So instead of going for the high capital investment, we created a new innovative closed loop system where the process of water, instead of going to the instead of going to the compressor directly to the process water used to go to the boilers through this route to the as a backup for the blowdown and losses in the system as well as tripping streams. So the process water which is going to the deaerator, the cold process water going to the boilers is now diverted to the compressors, and through the compressors it is diverted to the condensate drum and then to the deaerator. So what is the benefits? It has achieved multiple benefits of one is avoided showering of the compressors, avoided the showering of these compressors, as well as provided the redundant water supply to waters, since this process water is coming at a lowest temperature. So it is always ensuring that the compressors will never trip. The instrument air quality will be the highest because of the low cooling water temperature. The moisture separation will be good. The instrument air quality is good. And the water, instead of earlier, this process water, when it goes directly to the boiler, it's a cold water. Now it became hot water because it's recovering the compressor's waste heat. What we are doing is we are recovering the lowest quality waste heat from the compressors and we are putting into the boiler. So we converted into energy efficient while handling the process challenges. So the innovation really bring down the cost of this the capital required, and it provided as an incentive, like we get the payback within 3 months, and it conserved about 90 million gallons of water yearly. We enhanced compressors reliability and efficiency, saved 8,000 million BTU per year while reducing the emissions. You know, the water for desalinated water we use mostly in the Middle East, and production of the desalinated water involves huge amount of energy required, as well as discharge of some brain water into the sea during the process. So what we did after saving this water, we released this water and we reduced the 50% of supply from our supplier, and that was released to the industry. So what we saved is 90 million gallons desalinated water, as well as improved the whole system with a simple buyback of within 3 months, and we removed that portable compressors. So it shows that the process safety challenges sometimes provides an insights challenges which can make you even resolve them and start in converting into an opportunity where it has won even a global accolades recognitions, which saved a lot of money, water, emissions, as well as improved the whole system. So a challenge is really became into opportunity, a cash cow for us. Let me go to the second case study where we are handling up the fuel oil tanks. These fuel oil tanks, which are going to supply the fuel oil to the refinery as a circulation system, as well as crude column bottom pumps of seal, gland seal. So what happens is these tanks have no temperature control. It's a manual control directly from the boilers. It goes directly from the boilers. So the fuel oil supply is very critical because it cools the crude column bottom pumps, and any failure will cause process upset. Because as you know very well, that crude column bottom pumps RCO or the fuel oil, it is very close to auto ignition temperatures, and any failure of this fuel oil gland supply can potentially cause fire. So, and any upset in the bottom pumps will upset the column operation and cause back pressure. So multiple types of failures and risks are there. And one of the causes for this is, one is the manual tank temperature control, and second is by using the high pressure system, the erosion and corrosion is very high in these coils, and the coils have a history of frequent failures. The frequent failure of the coils, what will happen is whenever there is a failure, the water comes into the fuel oil, and then when it goes to pumps, it can cause a pump failure. So it can cause an emergency for the plant, which the procedures are there, but what we need is procedures and all comes at a later stage. But if you have an engineering controls and the upfront, it helps it better to overcome all the process safety challenges much more effectively. What did we do is, instead of only providing auto temperature with control by interlinking this tank temperature with a control valve, we converted this into an economic project by substituting the boiler steam. We isolated the boiler steam, and what we did is we routed the turbine exhaust, the 10.5 the boiler steam, which is driving the turbine fuel oil pumps, is getting exhaust. The exhaust is routed as the heating media for the coil. As a result, what did we do? We eliminated the operator's intervention. We reduced the boiler load, and this waste stream earlier is going to the condensers is now doing the job of heating the system. So we reduce the emissions, we reduce the chemicals blowdown, and the whole payback period is 6 months, and it eliminated the risks of if uncontrolled temperatures, you see the temperature if run away or some more than 100 degrees, it's crossing the design temperature of the tanks, and the tank's integrity is affected. The coils now have no leaks after conversion, after modifying this, so the coils reliability has improved. You don't need to do T&A of this. So many of multiple side benefits apart from ensuring that crude column bottom operation is much more is risk free now. So all the challenges has thrown an opportunity at the same time. The most obvious point of our sharing the purpose is most of the people there's a misnomer in the industry sometimes the safety is an investment which will not pay. But here we are showing the way that the safety can throw in opportunities where you can start even generating some income. So after the payback 6 months, we are generating now revenue from both the cases. And as a result, as you can see here, there are multiple levers, and moreover, whatever the refinery is always ensured that the systems are ISO certified, so that we have continuously systems upgraded and also engaged. And the result of them is these awards from EAE, Energy Manager Today Award, MEOS. So energy leaders. This is giving us a motivation to do more and to spread the benefits across the industry. Let me summarize this that a refinery explored all potential human errors which can cause upsets to minimize those risks. By exploring these human errors, then we converted these process risks into opportunities by innovation. Innovation, as a result, as I said, resolved several system constraints with minimal investments. As I said, the capital required has been come down by 50%, and also we have secured the new projects because for the new compressor, we did not lay another pipeline or upgrade the cooling water system. So it becomes easier to secure the project. We improved our system's integrity and helped to improve margins, improved water and energy KPIs, a conserved desalinated water, and we reduced the emissions. The innovation has been established and made in YRD culture. It has bring more people into the innovation channel and also promoted collaboration, decision making, and critical behaviors. And Yambu Refinery has won several global recognitions with these efforts. And I thank you very much. And I also let me record my sincere thanks to Yambu Refinery Management for providing me this opportunity along with my colleague Amodi, and also the organizers for giving an excellent platform to share our best practices with the industry professionals, so that we are all together make a safe journey into the future. Thank you all. And any questions, please?
Thank you very much. Okay, thank you very much. In the interest of time, we are going to need to move straight on to our next finalist. So once again, please welcome from Saudi Aramco, it's Arafat Al Oghali.
Yes, thank you very much. I don't know if you can see my screen.
Yes, we can. We can.
Okay, so let me just reduce this. little bit. And so thank you for the introduction. My name is Arafat Al-Ukeli. I work for Saudi Aramco Loss Prevention Department in the Risk Assessment team. And I'm here to present to you the hybrid approach for land use planning as part of this event. And I really welcome the opportunity. So just to get some background, why this is important. Land use, well, first, probably Saudi Aramco is the world's biggest oil and gas company, and it has the legal right to access land in the eastern province of Saudi Arabia to develop resources and access vital resources for the development and of the nation and for supporting sustainable development in the country. So the eastern province is an area that is bigger than some of the European countries, and there. So this is a huge land, and there is a lot of reserves that are close to public communities. So land use planning is very critical to allow access to the resources without infringing on the public right to develop some of these lands for supporting economic development. So basically, the traditional way that we have been managing land use planning is based on a prescriptive approach. We have set back or exclusion distances around hydrocarbon facilities that are dictated by government regulations and made their way to the company standards. And to add to that, we did have traditionally a bit of ineffective off-site emergency planning for different reasons and factors, so we have to keep that in mind. So the fixed setback distance that used to be the way we manage LUP was basically a fixed distance. Most of the time it would be around 500 meters from the fence of our facilities or pipeline corridors, regardless of the potential hazard in the facility or the facility type, whether it is processing, refining, or even transferring products, and also regardless of the potential risk posed to the communities. You know that some of hydrocarbon products would have different risk profile or would pose different risk level to the public than others. If you're processing a toxic gas, that's going to be different than if you're really transferring stabilized crude product. So the traditional way did not acknowledge those differences. To add to that, we have recently been facing increasing urban development and population growth around our community, our facilities, and that made it difficult to access land for development because the company would have to comply with these distances, so we'd have to reserve the land. We faced a lot of legal challenge sometimes, community or individuals challenging the company's decision to reserve the land. That caused a bit of a challenge to us. And we need also to keep in mind, on the other hand, that the environment we operate in here in the country tends to be more of a risk-averse environment. So people and the stakeholders, generally, our stakeholders, expect the company to manage the risk with minimal involvement of the public. And I want you to keep those factors in mind as we talk about the new approach that we have to develop or come up with for land planning, land use planning. So with those factors and realities, we have to basically come up with a hybrid, an LUP management approach, which we call the hybrid approach, that has to maintain a balance between the public need to develop the land, the access land for development, especially near urban centers, and company operations that is growing. We have recently been increasing our assets in the country, but we also need to account for the reverse aversion environment in which we operate and reflect that in our approach. So with that, we could not really use a ready-made or follow a ready-made approach we had to develop sort of a unique approach that fits our own needs, environments, and restrictions and limitations. So what we did is that, as everybody else would do, we started by conducting a detailed benchmark with international practices. We looked at different jurisdictions from North America, Europe, European countries, Asian, and Australia. We also did a very thorough review of the regulations, government regulations, and company standards to understand basically the comparison between existing practices versus requirement that we have to comply with. On the other hand, we have conducted a large amount of quantitative risk assessment for our different facilities. We grouped them into categories, similar facilities, and we tried to draw some conclusion based on that. We did conduct a lot of consequence-based assessment to determine potential impact zones or hazardous zones, and we looked at the fixed spaces that we had in our regulations and standards, and we kind of summarized that into our risk assessment guidelines to come up with the hybrid approach that we use for land use planning, or developed for land use planning rather. So it is really a combination of a risk-based zones, which is similar to international practices, but with the addition of exclusion zone that is based on either consequence modeling, impact zones around our facilities, or minimum setback distances that would be dictated by certain regulations and company commitment to protecting the public safety. So we could not really avoid those setback distances. So that's why we call it a hybrid approach, because we combined our traditional way of and local requirements and regulations, along with the international practice of looking at the risk-based approach, which is based on a proper management of process safety of in our facilities. And this approach ended up really accounting for the risk aversion environment and the stakeholders' expectation that we need to manage the risk in our facilities with minimal involvement of the public, along with the fact that, or the allowance to release some lands for development while maintaining access to some reserves. To give you an idea, some of our vital reserves are literally under cities and lie under cities and big urban centers. So we really need to be able to access these reserves. If we have to maintain big setback distances, we may not be able to develop these resources. And sometimes we don't need to maintain these big distances if we reflect the actual risk and conditions of these facilities. So just to illustrate, we had to illustrate the LUP hybrid approach. So we can look at this diagram here that shows Saudi Aramco hydrocarbon facilities in the center being processing facilities, production, or even pipelines, cross-country pipelines. We've got the exclusion zone that is based on a minimum distance, setback distance dictated by either security needs or consequence-based assessment. For example, we limit public exposure to anything within 100 ppm of H2S, highly toxic material, or risk level of 10 to -4 fatality per year, which is the maximum allowable risk to public that the public can be exposed to. So whatever the distance resulting from these three considerations, we consider it as, or we take it as the exclusion zone. Then we've got the non-residential zone, which is based on different levels of individual risk, and that is used for industrial or farming purposes. And then we've got the low residential zone, where scattered communities, small communities can be located. And then beyond that, obviously, you have the high residential zones as well. So just to give you an example how this is applied in real life example, if you look at pipelines, pipelines are very important for Saudi Aramco because we own and manage a massive network of cross-country pipelines in excess of 20,000 kilometers. And the traditional regulations require us to maintain half a kilometer, 500 meters from either sides of the pipeline corridor. So this is roughly comes down to almost an area, if we have to reserve it, that is bigger than the entire country of Lebanon, just for pipelines. And a lot of these pipelines run within cities. So it is a prime land. It is a land that is needed for development and costs a lot of money to reserve that land. And sometimes the solution would be, or the alternative solution would be to relocate some pipelines, which is also very expensive. So if you look at the pipelines, refined product pipelines, sales gas pipelines, the majority of them that run within cities, under the new hybrid approach would be required only to maintain 100 or 200 meters setback distance as opposed to 500 meters. When it comes to high-risk pipelines like the NG and NGL and LPG or sour products, then we would be using a bigger distance. So this approach actually kind of have risk management and proper process safety management practice built into the actual assessment. All these distances were developed based on detailed quantitative risk assessment that took a lot of time and effort to be developed and summarized into these guided distances. So with that, we have adopted a hybrid approach that's quite unique to our own environment and conditions, which reflects a risk-based planning, land planning around hazardous facilities with a minimum setback distance, and allow us really to maintain safety with the public while allowing the release of the land, much needed land, and access to our resources. All of this helped us develop several guidelines for different facility types. Some of them have been actually presented in the IChemE previous conference last year. So we have implemented this, couple of examples to show where this approach has been implemented. We did a town development plan around Riyadh refinery. This is a big refinery that's taking a big footprint, and if we had to maintain the traditional setback distance, the company would have to reserve really huge land near the capital of the country. That would have costed a lot of money. With the implementation of the hybrid approach, we found that some of this land, or the majority of this land, would be released for industrial use without really exposing the public to risk or jeopardizing the safety and security of our facility. We did the same thing for a refined product pipeline between Yanbu and Jeddah. This pipeline, part of it goes through the Jeddah city, which is the second largest in the nation. And again, traditionally we would have to reserve big land in the city, which would have costed a lot of money. But we found, based on risk levels, that is not needed really, and we were able to adjust that. At the same time, another example, we also managed to help with urban planning and development in Riyadh city, which is the capital of the nation, a big city of 5-6 million people, and we managed to help support the government plans to develop some neighborhoods without really impacting our assets and our facilities in the country. In a sense, we managed to achieve significant cost avoidance. I can't talk about the numbers, but believe me, it is a lot of money even for the country of Saudi Arabia. And all of that was done based on proper implementation of process safety management principles. A lot of people do not really understand when you process or handle or manage or deal with land use planning, there is at the underlying or behind the scene or behind the surface, beneath the surface of all of this is really the proper implementation of process safety management and risk management practices. A lot of quantitative risk assessment, a lot of good process safety practices and principles, guidelines have been implemented to achieve that. Another visual example here, we have a refined product facility storage highlighted in this image here. And under the traditional guideline, we would be required to reserve this land, you see here. But under the current hybrid approach, the land that would be required to be reserved would be much smaller. So we're able to release a lot of land, prime land for industrial, farming utilization, for public transportation, for even residential areas. And we avoided a big cost and reservation of land unnecessarily. That would have unnecessarily been reserved under the previous planning approach. So in essence, we have developed a unique hybrid land planning management, land use planning management approach that is really based on proper process safety management of our own facilities, which allows for the release of much needed land while maintaining risk to the public within acceptable limits. We supported in essence, the sustainable development and saved unnecessary costs to the company and the society. And we managed to change the practices in Saudi Arabia. We actually worked with our stakeholders and government agencies and ended up adapting our approach and made it into government regulations and to company standards. So we had actually a win-win solution that is unique, quite unique for us, and developed based on our own limitations and conditions. And that is really the strength of this approach. With that, I end my presentation, and if there is any question, please feel free to ask. Thank you.
Okay, thank you very much. So once again, we'll pause for questions. We have a first question. Is this process extendable to others in other regions, or is it Aramco specific?
Well, this is a very interesting question because you know, Saudi Aramco is the only oil and gas company in the country. So so this is basically really the only player in town, if you will. But at the same time, we know that from our interaction with other assessments and other types of studies that a lot of players in the region like to benchmark with other companies and other peers within the region. So we believe that this will have an impact beyond Saudi Aramco. We did manage, as I said, to present a paper in the IChemE last year, and it was very well received and generated a lot of interest and the questions. So I'm hoping that people saw the value of this. The key point here really is the fact that we did not adopt one solution or the other. We actually catered and customized practices to meet our needs given our conditions, stakeholders' expectations. So the same methodology could be applied by other people, maybe the requirement, the expectations, the regulations, or even the company's philosophies and policies can set certain limitations. So those can be built into this process to produce something that meets the requirements of different operators and different jurisdictions. And okay. We're happy to share even the some of these practices. We did publish some of that in the IChemE, but we're happy to share. If anybody have a question, we're quite happy to share some information as well.
Great, thank you very much. Right, it's time to move on. So thank you for that presentation. We have now reached our final finalist. Please welcome once again from Saudi Aramco, Mohammed Fahad Al Mulhim.
Yes, thank you. So, are you seeing my screen? It's clear?
Yes, we are. Yes.
Okay. Thank you for giving us the opportunity today to present one of Saudi Aramco initiative, which is Process Safety Excellence Initiative. My name is Mohammed Al Mulhim from Saudi Aramco's Loss Prevention Department, working as a process safety engineer. I will start my presentation with the main objective of the Process Safety Excellence Initiative, is to review and improve Saudi Aramco's process safety performance and adapt best-in-class process safety practices in order to ensure management systems were implemented effectively throughout the company. Ultimately, its aim was to protect people, assets, and the environment by preventing process safety incidents. The initiative focuses on three main areas: improving human capabilities, simplifying processes, and enhancing operational discipline. Throughout the Process Safety Excellence Initiative, the company was able to enhance process safety governance, improve competency and performance measurement, and ensure continuous improvement in this area. Now I will share with you an overview about this initiative. First of all, the initiative was formed by a steering committee consisting of managers from 9 different organizations across the company, and a working team with representatives from all stakeholder departments. 16 implementation plan teams composed of a subject matter experts were established, each member carefully selected based on their discipline. Each implementation plan was broken down into 3 phases. First is to design a solution or enhancement to address their assigned recommendations. Second stage is the piloting the enhancement at selected role model sites. And final stage is implementing the enhancement at all facilities across the company. This slide shows the 16 implementation plan summary of process safety management distributed under 5 major categories. The implementation plan teams focus their efforts on 3 main areas: improving human capabilities, simplifying processes, and enhancing equipment integrity, and addressed gaps related to management systems, process safety implementation at the site level, organization and capabilities, governance and performance management, and finally, process safety vision and strategy. Now I will share with you some of the outcomes of this initiative. Since the Process Safety Excellence Initiative's establishment in 2016, a significant positive trend regarding process safety incidents were achieved. Process safety incidents with high consequences were reduced from 25 in 2016 to 4 in 2019. This improvement was driven by the initiative through enhanced governance and commitment to process safety, improved process safety competency, and measurement and continuous improvement. With regards to enhanced governance, several new corporate general instructions were developed to provide guidance in several process safety topics, such as management of change and BHA. In addition, standardized and risk-based checklists for PSSR and preliminary hazard analysis were introduced. 8 life-saving rules based on safety issues that accounted for 90% of all fatalities during the last 10 years were developed and communicated to all Saudi Aramco employees and contractors. In addition, in terms of process safety competency, several skills-based in-class training courses were created, such as management of change training for the MOC coordinators, work permit training for issuers and receivers, gas testing training, confined space training, and lockout tagout training. In addition, a process safety committee of practice platform was also established, throughout which 8 roundtable meetings covering topics such as MOC, BHA, PSSR, incident investigation, process safety KPIs, and risk management were conducted. In relation to performance measurement and continuous improvement, facility-level leading process safety KPIs were developed and monitored at hydrocarbon handling facilities. Moreover, tools such as a corporate safety dashboard, providing a quick reference to organization safety performance through a combination of leading and lagging performance indicator was developed. Finally, the Process Safety Excellence Initiative was able to make significant improvement to enhance process safety across the company. And by this, I end my presentation. Thank you for your listening, and I will be glad to answer any questions you may have.
Okay, thank you very much. So we do have a moment for questions. If you have one, please type it into the questions box. And while we give you a moment on that, if you're enjoying today's webinar, there's still time to register for our remaining sessions. This afternoon, we'll be announcing our Farmer Award winner. Tomorrow, we have our Sustainability and Team Award webinars before we wrap up on Thursday with our Young Researcher Award, followed by our top prize, the Outstanding Achievement in Chemical and Process Engineering Award. Okay, then we don't appear to have any questions, so we will move on. And it's time. You've been waiting for. It's time to announce the winner. But before we do that, let me thank all of our finalists for being with us today and for telling us more about their work. I'm sure you'll agree we've heard some Very different, very interesting presentations. So let's start with our highly commended entries, and they are from Saudi Aramco and ABB. So well done to everybody associated with those projects. But now I'd like to hand back to Shona Turner from PM Group to announce the winner.
Hi everyone, thanks for a really enjoyable day. So ladies and gentlemen, the winner of the IChemE 2020 Process Safety Award sponsored by PM Group is Advanced Analysis Australia.
Well, congratulations to Advanced Analysis Australia. And Madhat, if you're still around, congratulations. How does it feel to be an IChemE Award winner?
Oh, we're very proud. I can't wait to announce this to the rest of our company and the world in general. We're very proud of this award. It's make us very happy, and we did the right decision by staying up late and missing football practice today. So thank you very much. Yeah, I'm lost for words. Really didn't expect it. Thank you very much.
Well, thank you very much. And yes, thank you for staying up with us for a late night. And a big thank you to all of our finalists for their presentations. And of course, our sponsor, PM Group. That wraps up today's webinar. Don't forget, there's still plenty more to come. I hope to see you on some of the other sessions. But for now, goodbye and congratulations to Advanced Analysis Australia, winner of the IChemE 2020 Process Safety Award.